You know, for all of human history, we've looked up at Mars, just this cold red dot in the night sky. But what if I told you that rock, that dot, was once a lost world? A blue planet, maybe even teeming with life? That's what we're digging into today, the incredible story of Mars, a planet that might have figured out the secret to life long before Earth ever did.
So let's just get right to it. Have we found life on Mars? It's the question, right? And a little while ago, the headlines just exploded. They found life on Mars. But you know how it is. The real story is always a bit more complicated, and honestly, a lot more interesting.
Okay, so the whole story kicks off in a place called the Jezero Crater. Now, we know for a fact this place used to be a giant lake fed by a river. And NASA's Perseverance rover is tooling around in there, and it stumbles on these rocks. Mudstone rocks with these weird spots all over them. They're calling them leopard spots, and believe me, they could be the key to this entire mystery. But here's where we gotta be really careful. Listen to how the mission scientists are talking about this. Dr. Ed Cludas put it perfectly. He said, look, we haven't found life on Mars. What we found are the possible remains of life. So we're not talking about little green men here. We're talking about fossils. Chemical ghosts of life that might have existed billions and billions of years ago.
So this is our first big clue. This is where our whole planetary detective story really begins. A sign that maybe, just maybe, Mars was once alive.
But to really get why these spots are such a huge deal, we have to go back. I mean, way back. Billions of years. To a time when Mars wasn't red, it was blue. A lost paradise that might have been an even better place for life to start than our own planet.
Picture this. It's about 4.5 billion years ago. Mars is born, pretty much the same way Earth was. It's got a hot, dense core, a rocky mantle, and a nice, thick atmosphere. As things cool down a bit, a massive ocean forms. We're talking maybe a third of the whole planet is underwater. All the while, volcanoes are erupting, asteroids are slamming into it, and all that activity creates a greenhouse effect that keeps the planet warm. It had clouds, it had rain, it had rivers carving valleys. It was a world.
And get this, the rain falling on this young Mars, it was probably acid rain. Sounds bad, right? But here's the twist. It was actually a good thing. As this acid rain fell, it broke down the rocks, releasing all these minerals and nutrients into the water. Scientists have a great name for this. They call it a chemical buffet. I mean, it's the perfect all-you-can-eat meal for any tiny little microbes just getting their start.
But you knew there was a but coming. This paradise had a secret, a fatal flaw buried deep inside the planet that was about to bring the whole thing crashing down.
Sometime between about 4 and 3.5 billion years ago, the planet's engine just died. The molten iron core, the very thing that was keeping it alive and protected, started to cool down and freeze solid. And that one thing, that was the beginning of the end.
So why is a molten core so important? Well, it acts like a giant dynamo, creating a magnetic field, a magnetosphere. Think of it like a planetary force field. It protects the atmosphere from the sun's solar wind, which is just this relentless stream of charged particles. Without that shield, you're a sitting duck. And Mars, well, it had just lost its armor.
And here's how a planet dies. Step 1, the magnetic field goes away. Step 2, that solar wind just slams, unprotected, into the upper atmosphere. It's like a cosmic sandblaster. It hits the air molecules and just knocks them away, flinging them out into space. And molecule by molecule, the atmosphere gets thinner and thinner. The pressure drops, all the warmth escapes, and the planet freezes.
So the fatal blow was struck, but it wasn't some big instant explosion. It was a slow, agonizing decline, the long goodbye, as Mars slowly turned into the frozen desert we see today.
And right around 3.5 billion years ago, you have this incredible fork in the road in our solar system. Over here on Earth, life is taking off. Photosynthesis is starting to pump oxygen into the air. But on Mars, the exact opposite. The atmosphere is bleeding away, the planet's getting colder, and any life that might have started is now in a desperate, losing battle for survival.
But Mars was a fighter. It didn't go down easy. You had these absolutely colossal volcanoes, like Olympus Mons, still erupting. And every time one blew its top, it would pump a ton of greenhouse gases into the air, giving the planet these brief, temporary fevers. It would get just warm enough to melt some of the ice, creating these insane flash floods. If there was any life left, its last hope would have been to go deep underground, huddling around geothermal vents, hiding from the deadly surface.
But by about 1 billion years ago, the fight was pretty much over. The average temperature on the surface had dropped to a mind-numbing -60 degrees Celsius. Just think about that. The warm, blue world was a distant memory. All that was left was a frozen tomb.
And that brings us right back to today. Back to Jezero Crater and those weird leopard spots. Because now that you know the whole tragic story of Mars, you can understand why this find is so electrifying.
So, what are they? Well, chemically, they're spots rich in iron minerals. But here's the kicker. On Earth, whenever and wherever we find this specific combination of minerals and organic material, it is always, 100% of the time, linked to biology. It's not proof, not yet, but it's about as close to a smoking gun for ancient Martian life as we have ever gotten.
Okay, so to get the final answer, we have to get those rocks back here. Perseverance did its part. It's drilled the samples and sealed them up. The next step is this wild, almost science fiction mission planned for 2030. We're going to send a whole new set of robots to Mars to pick up those samples, launch them back into orbit, and then another spacecraft will catch them and fly them home, hopefully by 2031. Then we can get them into our best labs and finally know for sure.
And this all leads to one last, absolutely mind-bending idea. We know for a fact that big asteroid impacts on Mars blasted rocks off its surface that have actually landed here on Earth. So, what if life got started on Mars first, back when it was the warmer, wetter world? Is it possible, even plausible, that a microbe hitched a ride on one of those rocks and seeded life here on Earth? I mean, think about it. Could we, all of us, actually be Martians? The answer to that question is sitting in a rock waiting for us on a cold, distant world.